Hello everyone. Today we're going to talk about thermal radiation, one of the ways heat moves from one object to another. There are three main ways that heat can transfer from different objects: conduction, convection, and radiation. Today we'll focus on thermal radiation because it's the way that heat can travel without needing a material. This means that even in empty space, when there's no air or no solid matter, thermal radiation can still happen. So what is thermal radiation? It's the energy emitted as electromagnetic waves from any object has a temperature above absolute zero, which is zero of Kelvin degrees. So all objects that are hot release thermal radiation. For example, the sun is very hot, so it releases a huge amount of energy. Next, electromagnetic waves are waves that travel really fast through space. These waves can have different wavelengths. The wavelength is the distance between two peaks of a wave. For example, radio waves have long wavelengths, while X-rays have really short wavelengths. The thermal radiation we feel from hot objects like a heater or the sun mostly falls in the infrared range, which is a type of radiation that we can feel as heat but can't see with our eyes. Next is we can learn about the ideal object, which is the perfect black body. To understand thermal radiation, we start with an idea of a perfect object called a black body. This is an object that absorbs and emits the maximum possible amount of thermal radiation. In reality, no object can be a perfect black body, but we use this concept as a reference. A black body absorbs all radiation that hits it and also emits the most possible radiation. So the emissive power is the amount of energy that an object radiates per second per unit area. So we can calculate the energy radiated using a formula called the Stefan-Boltzmann law. This law tells us that the hotter an object, the more energy it radiates. So if you double the temperature of an object, it will radiate 16 times more energy. The radiation emitted by a black body isn't all the same wavelength. For an object at 300 Kelvin, which is about 27 degrees Celsius or 80 degrees Fahrenheit, the radiation is mostly in the infrared range. But as the temperature increases, the radiation shifts toward shorter wavelength. This is why objects glow when they get hot. For example, the surface of the sun is about 5800 Kelvin and it emits mostly visible light, along with lots of energy in the UV and the infrared parts of the spectrum. Most objects are perfect black bodies, so we used a term called emissivity to describe how well an object emits radiation compared to a black body. Emissivity values can change depending on the temperature and the type of surface. For instance, a tiny metal reflects better energy than a rough, dark surface that might radiate more heat. When radiation hits a surface, it can either be absorbed, reflected, or transmitted. These behaviors are described by absorptivity, reflectivity, and transmissivity. For a black body, it absorbs 100% of the radiation it receives, which is why it appears black. The transfer of heat between two objects also depends on their positions relative to each other. We use something called the view factor to describe how much radiation from one surface reaches another. The amount of heat transferred depends on the area of the surface and how much radiation they emit and their relative positions. So, to conclude, thermal radiation is a fascinating way heat moves, and even though it can get a little bit complex, understanding the basics of how heat and how radiation works is key to solving a lot of engineering problems. Whether it's designing energy efficient buildings or making solar panels and understanding the sun heat, thermal radiation plays an important role in the world among us. So thanks for watching this video, and I will see you in the next videos. Okay.